Okay, let's dive into this explainer. Today, we're tracking down the typical value in our data.
Seriously? How do you find one typical value hidden inside a totally messy sea of numbers?
Enter the mean average. It's our mathematical hero, a single number that perfectly organizes chaotic facts. Imagine Lucas, Laura, and friends sharing 24 superhero cards, but it's totally unequal. Think of it like Robin Hood math. We just add up the total, then divide equally. So, 24 cards divided by 6 kids, that means perfectly equal shares of exactly 4 each. Now, what's really interesting here is how the mean average lets us easily compare totally different groups. If Ash's mean is 9 across 6 students, their total score simply has to be 54. Let's see how this builds when we pit two completely different sports teams against each other. Look at this. Over 8 matches, the football team's mean average goal difference was exactly 1. And over 9 matches, the netball team's mean average goal difference was also exactly 1. So the crucial takeaway here, mathematically speaking, both teams perform equally well overall. But wait, look closely. That match 3 data stands out a bit, doesn't it? This brilliantly illustrates a huge 11-to-8 spike. It's super obvious in those tall match 3 bars. Meet the outlier. It's an extreme value that completely wrecks our neat typical data pattern. Here's the big question. Should we actually include extreme outliers when calculating our equalizing mean average? Because outliers completely skew our Robin Hood math, making that typical average super deceptive. Now for a mystery. If the netball average suddenly drops below 3, what's the missing data? An average under 3 means they need less than 27 goals total, but they already have 31. Meaning it's mathematically impossible based on the strict rules of how mean averages actually work. Averages neatly organize things, sure, but outliers hide the real story. What secrets are your numbers hiding?